The advanced EHF payload, heart of a system delivering unprecedented levels of assured networked interconnectivity to rapidly deployable maritime, air, and ground forces, flexibly, where and when needed, immune from denial of service attacks, available in all levels of conflict. The payload puts the advanced in advanced EHF. A highly advanced digital processor serves as a switchboard in the sky, providing an order of magnitude increase in capacity versus Milstar, while supporting thousands of direct and rapidly reconfigurable flexible network connections between users on a variety of operational platforms. The processor implements advanced security and anti-jam waveform features to maintain both confidentiality and undeniable availability of U.S., international partner, and coalition networks operating at multiple security levels and within separate security domains. As with Milstar, the advanced EHF payload supports user logon and communications at lower data rates, worldwide, anytime, without prior coordination, and in the most hostile environments imaginable. And like Milstar, the payload features highly sensitive receive equipment, capable of accurately processing lower power spread spectrum signals in the EHF band, enabling low probability of detection, stealthy communications in support of special operations. The payload's fast-hopping uplink and downlink phased array antennas can flexibly cover a much wider area of the globe simultaneously with high-capacity service. While both Milstar 2 and advanced EHF provide 6 1-degree spot beams which can be steered to anywhere in the satellite field of view via gimbal drive antennas, the advanced EHF phased arrays support an additional 6 1-degree shareable spot beams, instantaneously steerable to any location within the satellite field of view. Operational planners have the option of allocating the capacity associated with each shareable beam among up to 4 separate regions within the satellite field of view, done on a hop-by-hop basis in milliseconds, transparent to individual users. Even with each payload's ability to deliver high-capacity coverage to upwards of 30 separate regions, there still could be a need to provide higher capacity service to isolated users outside of these regions. Fortunately for such users, advanced EHF's phased arrays also deliver a new super agile service, an additional dedicated beam that can be instantaneously steered to accommodate on-demand coverage for up to 160 independent user positions. The payload's intersatellite crosslinks support assured worldwide reach without need for overseas fixed-site ground relays or host nation approval for their use. The advanced EHF payload improves on the crosslink capability, currently unique to Milstar, by providing a 12-fold increase in crosslink data rate while supporting backward compatibility with Milstar satellites. Next-generation high-resolution adaptive nulling antennas improve on yet another Milstar unique assured communications capability. The advanced EHF payload's complement of 2 nulling antenna systems provide 2 steerable 1-degree spot beams, in addition to those described earlier, which afford a special benefit for users operating in close proximity to enemy forces. Within a nulling spot beam coverage, user connectivity up to 8 megabits per second is maintained, even under a sophisticated adversary's attempts to disrupt communications through use of a jammer located within the same spot beam coverage. Under the direction of an integrated industry government team based at Northrop Grumman's Space Park Complex in Redondo Beach, California, the advanced EHF payload is fast becoming a reality. The digital processor design is mature. Engineering and design verification models for the digital processor have been developed at all levels. Unit engineering models have been integrated together with early builds of flight software into a design verification laboratory. The processor's demodulator, configurable onboard router, and resource control computers, security electronics computer units are presently undergoing tests in the laboratory. A dedicated software development facility is in use by a team accredited at CMMI Level 5, which is actively developing the estimated 450,000 lines of flight software code that will reside in the processor. Phased array antenna performance has been demonstrated. Engineering models from the chip level to the major unit level have been developed for the uplink EHF array unit, for the downlink SHF array unit, and for the phased array controller and high-efficiency converter units. The integrated engineering models are currently under test in the new phased array assembly and test facility at Space Park. The facility includes phased array production assembly bays, a near-field range, a compact range, and a specially developed test set to ensure phased array unit compliance with specifications. The crosslink subsystem units are in test. Engineering models for all principal crosslink units have been developed. The crosslink antenna reflector engineering model is currently undergoing testing. Space Park's mechanical fabrication facility has recently been modernized and is fully equipped to provide flight crosslink, nulling, gimbal drive, and earth coverage antennas, as well as phased array feed horns for the advanced EHF. Individual crosslink subsystem units have been configured into an end-to-end crosslink test bed, where the ability of the subsystem to make the connection between the payload's processor and the incoming and outgoing 60 GHz crosslink transmissions, using both legacy Nullstar and advanced EHF protocols, is being verified. An improved nulling antenna is in hand. Engineering models for all principal units have been developed and integrated into a nulling antenna subsystem design verification model. Performance is being verified in the same antenna test facility used for Nullstar. Payload component production facilities are in place. Our microelectronics production facility is manufacturing critical microelectronics for advanced EHF, such as 1/10 micron indium phosphide monolithic microwave integrated circuits for low-noise amplifier applications, which support an order of magnitude increase in capacity over Nullstar 2 at significantly reduced payload size and weight. Space Park's automated board assembly line is producing a myriad of high-density multi-layer boards for various advanced EHF payload units. A new high bay facility specifically outfitted to accommodate the complex integration and test of advanced EHF flight payloads has been constructed at Space Park. This facility simultaneously accommodates the payload engineering model and 2 flight payloads. The payload engineering model is currently being assembled on an advanced EHF LM2100 spacecraft U-frame and wing structures in the facility. A complex test set integrating MIT Lincoln Laboratories' OST-T terminal emulator, Lockheed Martin's Payload Support Equipment spacecraft emulator, and other equipment is in place to support testing for compliance with a mature payload specification in accordance with a detailed design verification plan. With detailed design complete, flight hardware in production, and integration and test facilities in place, the first flight payload is on track for April 2006 delivery to the Advanced EHF Space Vehicle Integrated Product Team based at Lockheed Martin Sunnyvale, California. Assured flexible connectivity where and when needed, provided by a highly advanced payload taking shape today thanks to the dedicated efforts of an integrated advanced EHF payload product team.